Am I audible? I hope I am audible. Please respond.
Yes, sir.
Okay. So in last class, there was some kind of a confusion. Actually, it is because of that in my timetable it was written that classes is from 11 to 12, and in your timetable it was given like um, 10 to 11. So that's why we missed at least one class. So maybe now we have rectified, and I have checked with my timetable in chart, and it is actually 10 to 11. Okay, so we'll continue in next class in the same time too. So every day we have 10 to 11 class. Okay, now if you have any doubt, you can ask. Otherwise, I will start from the last lecture where we have handled this. So any doubts so far? I think what was the last topic? Yeah, somebody asking doubt? Yeah. Any doubt?
No, sir.
No. So in last class we have discussed about so far we have discussed about differential equation, and we have discussed about the solution. And in last class we were discussing about the types of solution. We have seen that in many cases we have like no solution, unique solution, or infinite number solution. And also we have seen like n parameter family of solution, n parameter family of solution. I hope you remember this concept n parameter family of solution. I y x equal to e to the power x and after y and e to the power x. You can see that here you are getting, say like here you are getting y equal to e to the power x plus c, and so on. Here you can also get y equal to e to the power x plus c1 x plus c2 x square and so on minus 1 x and y. Okay, so here we have seen that n parameter family of solution you can obtain. Is that okay? And we also have seen that it is not necessarily true that the nth order differential equation will have n arbitrary constant n arbitrary parameter involved in the solution, right? But in general, when this equation is given in normal form, then we will get the number of parameters is equal to the order of the differential equation. So it was so here then based on this we try to define one more thing which is known as general solution. Yeah. So anybody want to tell the definition of general solution? Yes. No. So what is general solution here? No. A solution, the differential equation. Let us see. X, y, y dash up to yn equal to 0 is called general solution. It contains any other solution. In fact, it's all other solutions. Okay, so it means that here, for example, this, if you want to find out all the solution of y dash equal to ex, and that can be obtained by giving suitable values to these parameters. So it means that I can write y equal to e to power x plus c is a general solution of y dash equal to e to the power x. I think this is quite clear, and this you have already done in your previous classes. Is it okay? Now, here we may say encounter some other situation also. For example, you have this kind of equation. Example, y equal to xy dash plus y dash, right? So first of all, just look at that. It is a non-linear differential equation. Non-linear first order differential equation. So here we can see, we can find out a solution like y equal to cx plus c square. We'll see that how we can find it. Okay. So first let us see, and then we try to force. So first that we are able to find out two solutions. One is y equal to cx plus c square. Another solution is y equal to minus x square by 4. Now here, if you look at the order of the differential equation is 1, and number of the parameter available in this solution is also 1. So here we can say that it is one parameter family of solution, right? So one parameter family of solutions. But the problem is that this solution y equal to minus x square by 4 is not is cannot be obtained by any say particular value of c. So whatever value of c you want to give it here, you cannot obtain the second solution here, right? So here, such a solution is called. Yeah, this you have done or not, all of you? So can you respond? Have you heard about this singular solution?
No, sir.
No, sir.
So here we have a solution which cannot be obtained by this one parameter family of solution, right? So many times we call these kind of a solution as singular solution. And since this one parameter family of solution I cannot give all the solution of this differential equation, I cannot call this one parameter family of solution as general solution, right? So we cannot call it general solution. Now, first of all, I have to check that how we can obtain these two solutions. Can you tell me any method by which we can find out the solution of this differential equation? Have you done any kind of a method? Because it is also a simple first order differential equation. Have you done any kind of a method to solve these kind of a differential equation? I think one thing is very easy to verify, that these two are actually a solution, right? So how we can verify? You have y equal to cx plus c square. You can write down y dash equal to c here, and then you can check that here cx plus c square is equal to x into c plus c square. So actually it is matching. So first y equal to cx plus c square is actually a solution. And if you take y equal to minus x square by 4, this implies that y dash is equal to minus x by 2. And then you can see that minus x square by 4 is equal to x into minus x by 2 plus minus x by 2 whole square. And it is minus x square by 2 plus x square by 4, and actually this is also matching. So it means that both are solution of this differential equation, right? So first, now let us see how we can obtain this. It is not very always possible to find out the solution of nonlinear problems, but here we can say devise a method to find out a solution of these first order nonlinear differential equation. Here what we need to do here is simply differentiate one more time, right? So we will get y dash equal to, here you can get x y double dash, right? Plus you can take y dash plus 2y dash y double dash, right? So now what we can see here, you can write it here, y dash will be cancelled out here, or you can say not cancel out. So this implies that here we have 2y dash y double dash plus y dash. Here this has to be cancelled out. No. Minus y dash plus x y double dash is equal to 0 here. So this will be cancelled out. So what you will get here, y double dash plus 2y dash x equal to 0. Is it okay? I think we are getting, I'm not doing any kind of a calculation mistake here. Okay. So I think I have, okay. So here, this is kind of a pair of differential equation, right? This kind of a differential equation we have already seen, right? So how to find out a solution of this? So here we will simply say y double dash is equal to 0, or say 2y dash plus x equal to 0 here. Now y dash equal to 0 means you can say that y equal to c1x plus c2, and here we can say it is what, uh, simply y dash is equal to minus x by 2, and you can simply say that uh, different y equal to simply minus x square by 4. So here we got a solution y equal to c1x plus c2, but we need to satisfy, we need to find out c1 and c2, because this is a first order differential equation and we are expecting that we should have only one arbitrary parameter, not two. So here, to let us see that this is a solution here and put it back and try to see that can we remove one parameter here. So it is C1x plus C2. Let me write it here. C1x plus C2 is equal to x. Now y dash you can find out. Y dash is equal to C1 here. So it is C1 plus C1 square. So here you can see that it is matching, and so you are getting equal to C2 equal to C1 square. So it means that your solution is going to be y equal to C1x plus C1 square. So you have seen that we are getting two solutions. One solution is this, another solution is this, which I have written here. Is it okay? Is this okay, all of you? By the way, listen, all of you. I feel that you people are very shy in responding, right? This is a very elementary course, in the sense that here I'm teaching from the very scratch to say going to say high level, but I expect that you should say discuss your doubts, your query with me, and for that interaction is very very important, right? Otherwise I can straight away go ahead with the next topic and we can discuss that. So I believe that you will interact and we'll discuss each and everything
Hello, sir.
in the class itself. Yes, I will
Hello,
follow.
sir.
Yes, tell
Sir,
me.
can we solve the above equation using quadratic formula? Because we have a quadratic equation for y1 prime, y prime square, and so
Yes, yes.
so we solve
Okay,
the
but
quadratic equation and we get two solutions, and then
yes,
solve a
yes.
differential equation. So
So
is
you
it
are getting some
possible?
kind of, no,
No,
I'm
sir,
saying
like,
that here, so you can possibly solve that also. Let me write it
oh,
here, and then you try to see whether you are getting some kind of a solution or not. X y dash plus y dash square. Yeah, yeah. Tell me how to solve this. So y dash square is equal to, uh, yeah. Try to solve this and get me
yeah.
some solution.
Oh, okay, sir.
So here, as pointed out one of the student, y dash equal to minus x plus minus uh, x square minus basically it is plus 4y divided by 2. So we can get y dash plus, sorry, y dash equal to minus
So you're taking
x
y as
minus,
constant.
huh?
So you're taking y as constant.
Yes. Here I'm considering this as a differential quadratic equation in terms of y dash. I'm not taking y as a constant. Am I treating y as a constant here? It is like differential quadratic equation in terms of y dash. So I'm just finding out the roots of this equation. So y dash equal to this, and similarly y dash equal to minus x plus under root x square plus 4y upon. And then you can try to solve it. Right? Are you getting something new here from this? Okay, if you want to solve this, you can
So that
also
I have
get
to solve.
some kind of a solution. Okay. Now my point, okay, so this is another way to solve this differential equation. And as I pointed out, here there is a possibility of this solution which cannot be obtained by one parameter family of solution, right? So here the concept of general solution is like kind of a fading concept, that here I cannot call this one parameter family of solution as general solution. But in most of the problem we have discussed earlier, whatever n parameter family of solution we are getting, almost all other solutions can be obtained by n parameter family of solution, and mostly we call n parameter family of solution as general solution. But in this kind of a situation, in fact, you can see that while giving some counter example, I'm considering a differential equation which is not linear. So in case of non-linear, there is a possibility of this kind of a situation which is known as singular solution, right? So to avoid this say conflict between general solution and singular solution. Okay, one more example I have to give so that little bit more conflict will appear. So here we have considered this also, y dash minus y dash minus 2y equal to 0. I think we have discussed this earlier also. So here we got a solution like yx minus c1 e to power x into y2, sorry, y minus c2 e to power 2x. Right? So here the solution of this differential equation is given by this. Now, if you look at this yx equal to, so we are getting basically two different set of one parameter family of solution. So one set of solution is yx equal to c1 e to power x. Another one is equal to yx equal to c2 e to power 2x. Right. So it means that here, if I call this as both are one parameter family of solution. If I call this as a general solution, then this is pure singular solution. And if we call this as a general solution, then this is a singular solution, right? So here, the concept of general solution and this similar solution is quite confusing. So to avoid this, right? So here we will not use the concept of general solution or simple solution. In place of this, we use two new terminology, which is known as n-parameter family of solution. N means the order of equation, n-parameter family of solution, and particular solution. So here we can say the n-parameter family of solution we have already defined. So this we are replacing by general solution is replaced by n-parameter family of solution, and singular solution is replaced by particular solution. So what is particular solution here? Particular solution. If you are getting any kind of a doubt, you please ask. No? So a solution, a differential equation, which does not contain any parameter or constant, is called particular solution. So in place of particular solution, so in place of calling general solution or singular solution, we'll talk in terms of n parameter family of solution and particular solution. For nonlinear differential equation, we have both the concept of singular solution and general solution earlier in previous days, but now for linear, the n parameter family of solution and the concept of old general solution is both connected. Is it okay? So here we simply let me write it. Okay. So now once we define particular solution, then we define general solution. In terms of parameter n parameter family of solution and particular solution, we simply say an n parameter family of solutions of a differential equation will be called the general solution if it contains every particular solution of the equation. Solution of the differential equation. Are you getting my point? So to avoid the confusion between general solution and singular solution, we first define n parameter family of solution. What is n parameter family of solution? Solution which contains n parameter. Okay, simple. And what is particular solution? A solution which does not contain any parameter. Okay. Then based on this n parameter family of solution and particular solution, we define general solution, and we simply say an n parameter family of solution, a differential equation will be called a general solution. An n parameter family of solution will be called a general solution if it contains every particular solution of the differential equation. Is it okay here? All of you?
Yes, sir.
Okay. So I'm just giving you one small example, which. So what is the solution here? Yeah, please tell me what is the solution of this particular problem? I think this you can simply solve or not. You just tell me whether this kind of a problem is solvable or not, or you can solve
Yes,
it or
sir.
not.
Yes.
Yes, sir.
So can you find out the solution here, just quickly? Yes. One thing is very easy, that yx equal to 0 is also a solution here. I'm looking for some other non-trivial solution.
Sir, y to the power minus 1 by 2 equal to x plus c.
Y to the power 1 by 2 is equal to 1 upon x plus.
Sir,
Is it okay?
1 upon x plus c. Yes, sir.
Thank you very much. Thank you very much. Now here we can simply say that this is your terminology. This is your general solution because it contains one parameter equal to the order of the differential equation, and this is your singular solution because it not be obtained by this, right? But if I take c equal to 1 by c1, so I can write this as 1 by 2 power 1 by 2 equal to 1 upon c1x as 1 equal to C1 here. So I can also write, if we take C equal to 1 by C1, then I can write C1 upon C1x plus C1, C1x plus 1. And in this case, this is one parameter family of solution. But now it is also acting as a general solution. Why it is so? Because it contains this particular solution as well. Are you getting this point? Earlier, this was a singular solution. And this is one parameter family of solution. And then we define another one parameter family of solution. Now, this contains this also as a solution by taking C1 equal to 0. So if we take C1 equal to 0, then this so-called singular solution is also contained here. So we can call this one parameter family of solution as general solution. Okay, so you just look at this and try to concentrate on this and try to understand the concept of n parameter family of solution, singular solution, and particular solution and general solution. Is that okay? Now, moving ahead, this next concept, which is known as the existence and uniqueness theorem for linear ordinary differential equation, which I want to discuss a little bit later. But before that, I just want to review of the first order ODE. Okay. So, what is a review of the first order ODE? So here I just want to discuss one by one simple example of each concept, and then we'll proceed. Okay. So the first topic is separable equation. So these are equations which is denoted as f of y dy plus g of x d of x equal to 0. So which can be separated out, and we can simply solve this, and we can simply integrate, and we can get it to this. So this is known as separable equation, right? Or something else you have studied. Is this you have studied separable equations?
Yes, sir.
So just I hope I will just take an example and then proceed further. So it is like y dy plus x dx equal to 3xy square dx, with the condition is that y2 equal to 1. I hope how to use this initial condition you know, or we'll discuss it. Okay, so can you solve this? It is y dy plus x dx equal to 3xy square dx. First of all, we have to observe that this is a differential equation given in terms of separable form. So can you just check whether it is a separable equation? It means that you
Yes,
can
sir.
always find out. Okay, so can you just find out the solution of this particular problem where we don't use this condition? So let me remove this condition right now. Yeah. So just solve this problem and give me the solution. And I'm just assuming that you have done this. So if you, any one of you feel that they are having difficulty in understanding, please let me know. Okay. Yes. Somebody
Sir,
got the solution?
sir, is it
Yes.
3y square minus 1 is equal to c into e raised to 6x?
Just a minute. I'm just writing here. You are saying that it is 3y square minus 1 equal to
c e raised to 6x.
e raised to 6x. Okay, let me see. Okay, so first, so I got one answer, right? So first of all, try to see how we can obtain this, and then we try to use the condition given earlier, that is y2 equal to 1. We'll see that how we can utilize this. Fine. So first here we try to convert into a separable equation, right? So here we have y dy, and this x dx you can take it out, take that side, so we can get 3xy square dx minus x dx. So I can simply write this as x taken out, so it is 3y square minus 1 dx here, so it is y dy. So now 3y square is taken this side, so y dy divided by 3y square minus 1, and it is equal to x dx. Okay, so we got this x dx y dy equal to 3y, and now we want to solve this. Okay, so here I can use several things. So let me write 3y square minus 1 equal to t. So it is 6y dy equal to dt, or I can write y dy equal to dt by 6. So I can write this as y dy, I can write dt by 6, and 1 upon 3y square minus 1 can be written as 1 upon t equal to, here I have not done anything, so it is written as it is x dx. So I can write dt by t, and this 6 I am taking to that side, this 6x dx, right? Then we simply integrate, so we get ln t, and here if we integrate, it is 6x square by 2, so it is basically 3x square plus c. I think there is a small difference here, right? And this t is basically 3y square minus 1. So it is, I can write here ln of 3y square minus 1 is equal to 3x square plus. So we can write here 3y square minus 1 is equal to e to the power 3x square plus. So this is the usual solution. So I think there is a small problem in this term. There was some kind of a calculation. Okay. So now we have one more thing, y2 equal to 1. It is just to fix the constant given here. So now it is one parameter family of solution given here. Now use the condition y2 equal to 1. So it means that x equal to 2, your y is equal to 1. So put it here. So we can write 3 into 1 minus 1 is equal to e to the power 12 plus c. Right? So we can get here, it is 12 plus c is equal to ln 2. Right? I hope I'm correct here. So your c is equal to ln 2 minus 2. Right? So I can put it back, and I can write 3y square minus 1 equal to e to the power 3x square as it is, e to the power ln 2 minus 12. So this I can write e to the power 3x square. E to the power ln 2 is nothing but 2, e to the power minus 12. So I can write this as 3y square minus 1 equal to 2 e to the power 3x square, and so this is your solution. This is basically a particular solution of the differential equation. So if you have any doubt here, please let me know. Otherwise, I will proceed further. Is it okay here?
Yes, sir.
Okay. So here, the separable equation, differential equation can be solved by first writing the differential equation into a separable form, means fy dy plus gx dx, and then directly integrate. So integration fy dy plus integration gx dx, and so this integration is to y, and this integration is to c. So we can write the solution in this particular form. So if initial condition is given here, so you can find out the value of the parameter. Okay. So this is the concept of separable equation. Now we have OD with homogeneous coefficient. Now what is homogeneous coefficient? So we need to know what is homogeneous function first of all. So what is homogeneous functions? So let us say we have f of xy, and it is called as homogeneous function if I can write this as, yes, Okay. Yes.
F of tx comma ty is t raised to n into f of xy.
Okay. Okay. So here Tx, Ty is equal to t to the power n f of xy. If it is happening, then we call this as a homogeneous function of order n. So it is homogeneous function of homogeneous function of order n. Okay. Any other definition which you remember? So we can simply write this also, f of xy equal to x to the power n g of u, where u is equal to simply y by x. Or you can have y by n g of v, here v is equal to x. So any one of the definition you can use, and if satisfy any one of these definition, we call this as homogeneous function. The OD with the homogeneous coefficient means a differential equation where the coefficient of dy and dx are homogeneous functions. Okay, then it is called as OD with homogeneous coefficient. So we'll see how we can solve. In fact, these kind of a problem can be solved by assuming y by x equal to t or x by y equal to t, and then see. So I hope this kind of a differential equation is already solved by several of you. Is it so? Is it solved by you already?
Yes.
Okay. So can you solve this small problem? So it is xy minus y squared dx equal to x squared. So here this and this both are a homogeneous function of order 2. Okay. Now we want to solve this. Okay. So first of all, what we try to do here, we can simply write it here. Let us say dy by dx equal to xy minus y square upon x square. So basically, when we are able to write down solution differential equation like dy by dx equal to xy minus, okay, so it is f of xy, and this f of xy is basically homogeneous function of order n. Then we can, so here we can say that this is the homogeneous function of order 0. Is it okay? How we can proceed further? Yeah, so here we can simply write either y by x equal to t or x by y equal to t. So let us start with y by x equal to t. So when you take y by x equal to t, then I can write y equal to tx. If you have any doubt, please ask. Now we can write dy by dx equal to t plus x dt by dx. I hope I can write it here. Here I am using the chain rule, which you have done in your first year MAM's rule. Right. So in place of dy by dx, I can write down this term. So I can write it here: t plus x dt by dx equal to. Now here, first term I can write down as xy minus x square means y by x, and here it is y by y square upon x square. So this I can write here t minus t square. So this can be cancelled out. So we have x dt by dx is equal to minus t square. And then I can write it minus 1 upon t square dt equal to dx by x. I hope I'm correct here. So can you find out the value here? Can you solve this and tell me the solution y in terms of x? Just complete it. Please solve this. And if you have any doubt, you can simply ask.
Sir, x by y equal to ln x plus c.
So you got the solution. No? So you got x by y equal to ln x plus 1. Okay, fine. Now
Plus c.
here we have to, let's see. Okay. Now here we have to use the condition y1 equal to 1. Okay. So when you use y1 equal to 1 means x equal to 1, y is equal to 1. So it is 1 equal to ln 1 plus c. So you can get the value of c equal to 1, and you can write here as x by y equal to ln x plus 1. Or if you want to write in terms of y, I think here you can write down x by y minus 1 equal to ln x. So I can write here x equal to e to the power x by y minus 1. So this is your solution. Okay, so this is how we solve OD with the homogeneous coefficient. So if we have a coefficient of dx and dy as homogeneous function, then by letting one of this y by x equal or x by y as t, you can transform this equation into this kind of equation, which can be a separable equation, which can be solved easily. Okay, so I'm not going into further detail of this until unless you ask this. Okay, then I think there may be different kind of problems also. I think the coefficient will be linear equation. This also we have discussed or not? ODE with a linear coefficient. So I think linear coefficients means, what is linear here? Linear means something like ax plus by plus c kind of thing. So here we can simply say that we have a1x plus b1y plus c1 dx plus a2x plus b2y plus c2 dy equal to 0. Right. So I hope this also we have discussed earlier. Yes or no? Means you have done in your previous classes. Yes. Okay. Have you discussed this kind of problem earlier? If you tell me, then this can be done easily. If you don't tell me, then I have to solve this particular problem. So let me, I think, give you a method to solve this differential equation with non-homogeneous coefficient. So here, what you try to do, you take this
Sir, I
a1x
think
Your
plus.
screen is not
your
shared.
yes.
The screen is not visible.
Okay, just a minute, just a minute. So it is there. Okay. Now it is okay. Yeah.
Yes, sir.
So here, what we do here, the simplest way is that you take coefficient of dx as u. You call it a1x plus b1y plus c1 as u. Okay, and you can call this v as the other coefficient of dy, that is a2x plus b2y plus c2. Okay, and then you can simply write it du equal to a1 dx plus b1 dy, and dv is equal to a2 dx plus b2 dy, and then you can solve this for dx and dy. You can write dx and you can write dy here. So when you solve this, you can write something like c1 du plus c2 dv, and d1. Okay, I will use some other notation. And here it is c3 du plus c4 dv. I'll put it back. So when you put it back, then I can write here as u dx. I can write it here c1 du plus c2 dv plus v, and this I can write it here c3 du plus c4 dv and then you can simplify, and you can write something like du plus something like dv, and then you can simplify. Is it okay here? So can I just take an example and then proceed further? Is it okay? Is this way you have done it, or something else you have done it?
Yes, sir.
So let us do a simple problem. So exercise. So basically it is again converted to separable equation, which can be separable equation or coefficient with homogeneous coefficient, differential equation with homogeneous coefficient. So let me write here 3x minus 2y plus 4 dx minus 2x plus 7y minus 1 dy equal to 0. Let me check whether this is a okay. I hope that it is okay. So you just try to solve this. I think it is what 3x minus 2y plus 4 dx minus 2x plus 7y minus 1 dy. Oh, okay. So it is here. So can you just solve this? So here what you need to do, here you take u equal to 3x minus 2y plus 4, and v is equal to minus 2x plus, not it is this minus 7 plus 7y plus 1. It is plus or minus? Oh, it is plus. It is plus here, so it is minus. Okay, so this u and v is given to you, and then you try to solve this. So can you just do it here? Please do it. For example, you can write du equal to 3 dx minus 2 dy, and dv you can write it minus 2 dx, yeah, minus 7 dy. Can you solve this dx and dy? Dx equal to this and dy equal to this. Can you do it? Yeah, please do it. We just quickly finish this review part, and then we'll come to the course itself. This is the revision part. Yeah, just try to find out what is dx dy, and then try to solve this. Yeah. Yes. So what is dx here?
Sir, 7 dy plus 2 dv by 17
7 dy minus.
plus 2 dv by 17.
So it should not contain dy here, right?
Sir, du.
Okay, sorry. So 7 du minus
Plus 2 dv by 17.
2 dv by 17. Okay,
Sir, I
and
think
similarly
23
23.
in the denominator.
23. Okay, it should not be like this kind of error. I think here I am solving a very simple algebraic equation, right? So can I do it right now on my own? So I can write it here 2 du equal to 6 dx minus 4 dy. Here I can write 3 dv equal to minus 6 dx minus 21 dy. and I can simply add. So it is 2 du plus 3 dv is equal to minus 25 dy, and we can write dy as 2 du plus 3 dv upon minus 25, and put it back in one of the equation, we can get dx as well. So we can write du equal to 3 dx minus 2 upon 25. This equal to 2 du plus 3 dv, and we can simplify this also, and we can get. So this is a little bit calculative, but I think you can solve this. Okay. So whether you just confirm it, what is dx and dy, but dy at least is 2 du plus 3 dv upon minus 25. So du also you can satisfy. Okay, it is 75 dx plus 4. Okay, I can write it here. So I can write here 3 dx is equal to du minus 2 by 25 twice du plus 3 du. So we can write 25 du minus 4 du minus 6 dv on 25, and you can write it here as 21 du minus 6 dv divided by 25 dx, and then you can write it dx equal to 7 du minus 2 dv divided by 25. So neither it is 17, neither it is 23, it is 25 here. So the dx is this. dy is equal to twice du plus 3 dv upon minus 25. Okay, so once we have dx dy, then you can write it here as following. So first part is simply u, so it is u, and then dx, which is written as 7 du minus twice dv divided by 25 as this is minus v. So v I have taken as minus 2x plus minus 7. So the entire thing I have taken as v. So it is v here, and dy I'm writing as 2 du plus 3 dv divided by minus 25 equal to 0 here. So we can write it here. Say, so 25 you can take it out. So we can write 7u du, right, minus 2u dv minus 2v. I think here I have, okay, 2 v du minus 3v dv is equal to 0 here. So now we can simplify this, and we can write it here. 7u du is okay. 7u du. Oh, okay. Minus, I think, okay, minus 3v dv I have written here equal to twice u dv plus twice v du. Yeah. So is it okay here? So this I can write it here 2 times. I think this we can write it 2 d of uv, and this is 7u du minus 3v dv. Can I write it like this, all of you?
Yes, sir.
Fine. So now we can simply integrate here, because now it is just written in separable form. So we can write it here 7 u square by 2 minus 3 v square upon 2 equal to twice uv plus some constant, right? And then you can simply plug in the value of u and v, or you can simply write 7u square minus 3v square equal to 4uv plus 2c1. I think c1, okay, no condition is given. So here you have to plug in the value of u and v and just solve this in terms of x. So can you just complete this? This I'm just giving you to complete it. So in this way, you can solve the ordinary differential equation with the linear coefficient. Now, here there are several type of cases available in linear coefficient. So I think this was case one. So case one, when these are distinct line and they are intersecting line, and basically another case is uh, when x and y coefficients are in parallel. So if we have a1x plus b1y plus c1, and then here we can simply write a1x plus b1y plus c2. So here only say c1 and c2 are different. This is case 2, and we have case 3 where the exact so we can write a1x plus b1y. So this is the coefficient of dx, and plus is the coefficient of dy equal to 0. And b1y plus b1 dx. And then you have k times this a1x plus b1y plus c1 dy equal to 0. So here we have two more cases to be discussed. So just quickly, how we handle this situation when both the linear coefficients are like parallel other than the constant coefficients. So how we handle this situation? a1x plus b1y plus c1 dx plus a1x plus b1y plus c2 dy. So how we handle this kind of a situation here?
So we can express one line into another.
Okay, okay. So
Then
so
it
how
will
we
be the
can write
variable
this?
separation.
It should be. It should be written. Okay, so just we'll discuss a little bit. I think 3 minutes is there. So we can quickly 2x plus 3y minus 1 dx plus 4x plus 6y plus 2 dy equal to 0. So it is something like that. Okay. So here, if you look at 2x plus 3y, then it is simply 4x plus 6. It is just twice. No. So here, what we do, you write 2x plus 3y minus 1, right? Then you can simply write du equal to 2 dx plus 3 dy. Okay. Then how we proceed further?
Sir, I think 2x plus 3y minus 1 equals to u. Then the second term will be the 2u plus 4.
So it is 2x plus 3y equal to u plus 1, right?
Yes.
So this term, second term will be what? So it is 4x plus 6y plus 2 is equal to twice u plus 2 plus 2. It means 2u plus 4. Yes. Is it okay?
Yes, sir.
Okay. Then next, what is next here? So you are able to write this in terms of 2u plus 4. Then what? How to proceed further? Because generally, when you have two different u and v, then we are able to write down dx and dy in terms of du and dv. But here we are expressing both the linear coefficient in terms of one variable only. So then how we can handle it? Right? So in this case, when you have this, then you write down any of dx and dy in terms of du and the remaining variable. So for example, here you can write dx as du minus 3 dy upon 2. You can also write dy in terms of dx and du and put it back. So here you can write this u, and this is du minus 3 dy upon 2 plus twice u plus 4, and this is as it is dy equal to 0. So basically here we are not getting u and v. Here we are getting u and one of x or y. So right now here I have replaced x. So we are getting an equation in terms of u and y. Right. So can you quickly, okay, so we'll continue this and the next kind of example in next class. One more thing. So far I have not given any assignment. So maybe I will try to give one assignment today itself. because I was suffering from some kind of fever and cough. So I was not able to make this kind of a thing. So I will make it and then I will post it here. And I will also post the PDF of these three lectures also on the team. Okay. So with this, if you have any doubt, you be there. Otherwise, all other people may leave. So if you have doubt, ask. Otherwise, you may leave.
Sir, in the above question, we got term UDV plus VDU, and we wrote it as DUV. But will it always be suitable like that? Can we get other cases?
Which one? Which one?
In the
Yeah.
above example. No, above.
Oh, in this one. Yeah. So here we have to see here all the experience of your previous years is counted here. So right now it is written in D of UV. It may be some other format also is available. So here I will discuss one more topic which is known as exact equation, right? So that will also be helpful here. So right now I'm just giving you some example which is very easy. But if it is not, then you have to see how we can make it exact. So we'll discuss this again when we have when we discuss how to make an equation exact. Okay. So this I will discuss. Okay. Okay. Any
Yes,
other
sir.
doubt? No other doubt? Okay. Then I will